Okay, so we have a progressive wave here. We want to find the phase difference between 2 points on this wave. Let's say x and y. We'd measure the distance between those 2 points, and we figure out what fraction of a whole cycle, a whole wavelength that is, and then we'll multiply that by 2 pi. Okay, if we want to get phase difference and we've got time difference between 2 points, let's say reaching the peak or something, then we take that time difference and we divide it by a time period and multiply that by 2 pi. Okay, for a stationary wave, this is different. Okay, so for stationary wave, let's look at 2 points, say x and y here. We can see they're both oscillating between these 2 points here. So they have different amplitudes. So the particle at x has a larger amplitude, it can reach a larger maximum displacement compared to particle at y, which has got a smaller maximum displacement. However, when it comes to phase relationship, they're actually both in phase. If you look at it, they both reach the minimum at the same time and maximum at the same time. So for example, right now they're reaching the maximum and now they're in the minimum. So let's look at another point. So this point y here, and is oscillating between those 2 points. And if you look at it again, they both reach the minimum at the same time, right now. Okay, and the maximum right now. So actually, it turns out points that are set within a node, between 2 nodes, are actually in phase. It doesn't matter what the amplitude of that point is, they're actually in phase. Let's consider this point over here. Again, the particle here is oscillating between those 2 points here, so it's got a smaller amplitude. But if you look at it, they both reach the minimum at the same time and the maximum at the same time. So they're actually in phase. Those 2 points here are separated by 2 nodes. What about if they're separated by 4 nodes? So if they're separated by 4 nodes, again, they're in phase. Okay, so it turns out the rule is if 2 points on a stationary wave are separated by either 0 nodes or an even number of nodes, they're going to be in phase. Okay, let's consider point Z over here, which is oscillating between these 2 points. Now, point X and Z are separated by a single node, basically an even number of nodes. So if you look at it, as one reaches its maximum, the other is actually reaching its minimum. And as other one reaches its minimum right now, the point Z was reaching its maximum. So they're actually in antiphase. What about point Z over here, which is separated by 3 nodes? So that's still an odd number of nodes. So that one point reaches its minimum, the other is reaching its maximum. Okay, so this oscillating between those two points got a different amplitude, but they're both in antiphase actually. So points separated by an odd number of nodes are in antiphase with each other.